So lesson 11.2 is going to talk about area and then related topics in terms of area of circles and sectors. So this is kind of interesting how they come up with the formula for area of a circle, and it relates to what we know about parallelograms. So if they go ahead and they divide this circle into congruent sections, okay, and then they kind of rearrange these sections so we have this here, this parallelogram-like shape. Now the base here is going to be half of the circumference, right? Because these are each these outside rims of the circle, and it's only half of it because then this is the other half. So that's where they get 1/2 C. Okay, and then with that, we can go ahead, since the circumference is 2 pi r, if I take half of that, multiply by 1/2, that's how I go ahead, oops, the 2's cancel, and I'm just left with pi times the radius, which is what they've written here. So that's where those two relate. 1/2 of the circumference is going to cancel out the 2, and that gives us pi r. So my base of my parallelogram, we think of the formula for area of a parallelogram as base times height. The base of the parallelogram is pi times radius. And then the height of the parallelogram, well, this is the radius, right? That distance there, that is the radius. And so you can see how we can get pi r squared. Interesting how that came to be, and maybe you never thought about it or questioned it, or maybe you have seen it before, but the formula for area of a circle, pi r squared. And at this point, I'm sure that kind of just rattles off your tongue. Let's try a few just for good old fun, right? So they want us to find the missing indicated measure. They want us to find the area of a circle with a radius of 2.5 centimeters. So pi r squared. I'm going to go ahead and do pi. My radius is 2.5, and I'm going to square that. So I'm just going to type into my calculator pi times 2.5 squared, and it's going to give me an answer of 19.63. They don't tell me what to round it to, so I want to label it centimeters and squared. Make sure when we're doing area, you label it squared. The reasoning is, I know we're dealing with circles, but a square makes most sense. If I divide this into a bunch of, assume those are equivalent, okay, then I divide this here, whoa. These here are how many little squares, little square units fill up this space, okay? So it's like you would lay a grid on top of it, and it applies to a circle too. It's just less obvious because we have portions of those squares that are created, like some of these weird ones, but it all is accounted for kind of based on that formula up above. So anyways, that's what we're saying here. We're saying how many square units, or in this case, square centimeters. So another way of writing it is centimeters squared, but sometimes people wonder why that squared's there. Part B, though, diameter of a circle with an area that is given. Okay, so there is no alternative, like circumference has 2 pi r and pi times diameter. Area does not have two different versions, so we're going to use pi r squared. So that's pi times, pi r squared again. All that I can fill in here is my radius is 113.1. Okay, so I'm going to divide by pi on both sides. And then of that answer, I'm going to take the square root. Okay, so I'm going to go ahead, and I can really just write this as 113.1 over pi. So the square root of 113.1 divided by pi is equal to, r equals 6. The radius is 6. And you can check this. If I would do 6 squared times pi, I end up getting 113.1. So now that's my radius. I want to know what the diameter is. So knowing that the diameter is double the radius, I can easily say that my diameter is equal to 12, and we're talking about centimeters. Okay? This would be centimeters as well, but that's the answer they want. All right, let's move on to the next part. Let's talk about population density. So that's kind of a hot topic right now because it's hard. You can't just compare sometimes you can't just compare, land space and say this many people if you're not looking at the whole picture. So it's easy to kind of create misleading data if people aren't understanding how the data is distributed. So this concept of population density of a city, county, or state is measured by how many people live within a given area. Okay, so the population density is found by the number of people divided by the area of the land. Now, it's usually given terms excuse me, keep getting a tickle, of square miles, but you can use any units. You can use city blocks, whatever. So if we have a 1 by 1 mile, Okay, and we have people that live here as opposed to a 1 by 1 mile elsewhere. And we have people living here, there's a population density that's a lot higher, right? So that can really, to a number of things. If you're talking about the spread of things, obviously there's a greater chance if there's more people compact together. If you're talking about, reasons of where to locate different stores, something like that, you're going to want to locate your stores maybe in an area where there's more people. So those are just two quick examples. A lot of times when population density voting, different scenarios where this is an important topic, okay, how different things are played out. So we're just going to use that formula and find population density of some given situations. So in example A, about 430,000 people live in a 5-mile radius of a city's town hall. Find the population density of people per square mile. Okay, so I'm going to abbreviate this to population density. There's not like a variable I'm using at the moment, just that. There are number of people, 430,000. Per the area of the land, they tell me it is a 5-mile radius. So if this is the town hall, in a 5-mile radius is the area we're talking about. So let's find the area of that land. Okay, so that means I want to find the area. So pi r squared, pi times 25, because 5 squared is 25. And I can put that in. Right now I'm just going to write it as 25 pi, but I could calculate that out and it's about 78.5. So anyways, I'm going to divide 430,000 divided by 25 pi, and it gives me, now let's put our units in. This is people, and this is our units of miles, square miles, okay? Because we're talking about our area of that 5-mile radius, okay? All right, so then whenever I divide that out, I get 5,474.93 people per 1 square mile, okay, or miles squared. So in every 1 square mile on average, if you have this location, there are about 5,474 people, okay? It might not be exact, but it gives you kind of a breakdown as to how compact the area is. Okay, now letter B, let's move on to this one. So in this case, it says a region with a 3-mile radius has a population density of about 6,195 people per square mile, so it's higher. Find the number of people who actually live in that region. Okay, so the number is higher, but let's see, that is per square mile. So this relates, these are equivalent units we could compare. Let's see how many total people we're talking about, because this is within a 3-mile radius. So population density, I actually know, so I can fill in this value, or I'm sorry, this is what I'm trying to find. The population density is given of 6,195. What I'm trying to find, is the number of people. So I'm going to say it equals x over the area of the land. So the area is pi r squared, which is pi times 3 squared, or 9 pi. Multiply both sides by 9 pi. Those cancel, x comes down, and 6,195 times 9 pi gives me a final answer of 17,515. Oops, sorry. I had the wrong units there. Let's just write the numbers and then I'll call it out. It is 175159.5. Okay, obviously can't have half a person, people. So that is 175,159.5 people. Okay, so you can see how you can make numbers do different things. This is talking a 5-mile radius. Obviously there's this number here's in a 3-mile radius, there's this number, but unless you're comparing like the same units, it can be challenging to get an idea. So this would be their same units. And even at that, maybe that's not what you want. Maybe you want the total count. So different numbers mean different things, but give these a try. Keep this formula in mind and then the one for area, and we'll finish the lesson in the next part. Thanks, guys.